Hola a todos, gracias por reunirnos, por organizar esto.
Good morning.
Llevo en
Thank you
Hologate,
for this
soy
opportunity.
chilena, pero
Thank you
llevo en
for
Hologate en
organizing this
California
meeting.
21 años.
I'm a
Mi
winemaker. I'm from
trayectoria
Chile, but I have been working as a winemaker in California
Me
for
quería
21
enfocar en la
years,
parte
so I
práctica.
have made my career here in
¿Cómo,
California.
cuándo y dónde
I would
medir
like
el
to focus
potencial
on
redox?
practical aspects,
¿Y
how,
por
when,
qué es
and where
importante?
we measure the redox
Hace años
potential,
atrás,
and why we
5
should
años
do it,
atrás,
why it
fui a España
matters.
y vi
A few years
una
ago,
unidad para
5 years ago,
medir el
I
potencial
was in
redox
Spain,
en
and on
Matanza,
that
que es la
occasion I
bodega donde
saw
yo
a
trabajo.
unit
Tenemos
for the
6
measurement of
Sauvignon
the
Blanc.
redox potential. At Matanzas
Mucho
Creek, the
oxígeno.
winery where I
Entonces,
work, we
mi
have
idea era
6
varias
Sauvignon
ramas. Yo
Blanc.
estaba haciendo
I don't
un
use
Sauvignon
oxygen,
Blanc
so my
reducido, ¿no?
idea was to
Yo de todo
ascertain
el departamento
whether
de ventas hago un
what I
Sauvignon
was
Blanc
doing was
reducido.
really a reductive
Y esa
Sauvignon
fue la
Blanc or
primera
not, because I was telling
que
our
probé la
salespeople
unidad
that we
de
made that type
Electron
of wine. That was the
Y
first time I
la unidad
tested
que
the
nosotros
electron
tenemos
wine unit.
tiene un electrodo de platino,
Our
como
unit
explicaba Federico, con un
has
electrodo de
a
referencia.
platinum
Y estos dos
electrode, as
electrodos
Federico told you,
son
with
una
a
unidad,
reference
es una
electrode,
sonda
and these two
que se pone
electrodes
dentro del
form a
vino.
unit, a
Las
probe
unidades estas
that
son
is
en muy
placed
puestos
inside the wine,
y
and the unit of
generalmente
measurement
en la
is
literatura
millivolts.
uno lo encuentra expresado como
Usually, in literature, we
porque,
use the
como decía Federico,
acronym
no es una medida
EH
como es
because, as Federico
casualmente en
told you,
alquimia.
it is not a single measurement.
Todas estas
He
parejas
was talking
de
about a
compuestos
storm, all
que se
these
están
pairs of
midiendo,
compounds that are
la
measured
máquina mide cada 6 segundos y tú sacas un
because the
promedio de esa
machine
medida
measures at intervals of
y,
6 seconds,
y
and you
todo esto
calculate the
mide como
average
la
of these
fuerza
measurements.
electromotriz del
All
motor del
this
vino.
basically
Yo creo que este
gives us
concepto de
the
fuerza
electromotive
electromotriz
force of the wine must.
es más
I
fácil de
believe
entender
that
y de
this
explicar.
concept of electromotive force is easier to understand
Entonces,
and
esta
explain.
sonda que uno la pone en el mosto o en el vino,
This
más o
probe
menos la tiene que
is
dejar para
placed in the
estabilizarse
wine
de
juice
20 a
and in the
30
wine
minutos.
and must remain in
La
place
sonda
to
mide de
get
continuo,
stable
o sea que
for
uno la
20 or
puede
30
dejar durante
minutes.
todo el
The
transcurso de la
probe takes
fermentación
continuous measurements,
y
so you
es
can
muy
leave it in
bueno porque uno ve
place
los
during the
cambios
entire
en las
fermentation
variaciones que se
period.
hacen durante la
This is very
fermentación, ya
useful
sean
because
adiciones de nutrientes,
during
adiciones de
fermentation
glutathión,
it can be
remostajes que se
that
ponen
you add
haciendo para
nutrients or
medir los químicos.
glutathione or pump
Y
over if you use the
nosotros tenemos la
probe in red
capacidad de ver
wines.
esas curvas, esos
Through
gráficos
these
y ver
measurements, we
cómo
have the opportunity
uno
to
puede
see
asociar la
these curves,
percepción
these graphs,
nuestra del
and
vino
we can see
con los
how our
distintos
perception of
números
wine
en la
relates to
pantalla
the
de
different
potencial
values
redox.
of redox potential
¿Cuándo medir?
that are displayed on the
Como no
screen.
podemos medir, que sería lo ideal, los
When do we
metales
take measurements?
del mosto,
The
ya
idea
sea
would be
hierro,
to be
cobre o
able to measure
manganeso,
the metals present in the must,
es
whether
muy
it is
caro
iron,
y
copper, or
sabemos la
manganese.
influencia que nos ha
It is
dado
very
Federico de
expensive,
esos
and
metales.
we all know
No
the
podemos medir eso, pero
importance
sí
and
podemos medir el
influence of
potencial
these
redox.
metals. Federico told us about
Los
that.
tratamientos
We
de
cannot
campos
measure them, but we
para
can
evitar
measure the redox
polillo,
potential. Treatments
y
that are
otras
made in the
enfermedades.
vineyard to
Muchos de
avoid
ellos contienen,
diseases
como
such
ustedes
as
saben,
powdery
metales,
mildew or botrytis
los
often
metales más
contain
seleccionados.
metals, and in particular
También
the
las
metals I
adiciones de
was talking
azufre
about earlier.
eh,
Furthermore,
son
the
cruciales.
fundamental role of
Es muy
adding
crucial
sulfur must be
el
taken into
conocimiento
account.
que
As a
se le
result,
han puesto a
it
los
is
viñedos
essential
antes de
to be able to
la uvera
understand
bodega,
what treatments were
porque más
made
o
in the
menos tiene
vineyard
una idea
before
con qué va a
the
tener que
grapes
lidiar.
arrived in the cellar,
Entonces, mi
because in
consejo
this
es
way you
empezar a medir en el
understand how
mosto
the
para
initial
definir una
situation
medida
looks
base.
like. My advice, therefore, is to
Les estoy
start
mostrando en este
making the
minuto
first
un
measurements
gráfico
in the
de
must
un
to have
Sauvignon
reference
Blanc
values.
que hicimos
I'm showing to
muestreo
you the measurements of a
ya
Sauvignon
les
Blanc
llegó el mosto y
that we
empezamos a medir lo
sampled.
que estábamos haciendo.
So
El primer año
we
no hicimos ningún
made
cambio.
measurements of the must. The first year we did not make any changes. When these grapes arrive, they are pressed, and during the pressing process we use a lot of dry ice pellets, and we start taking measurements already at this stage to be able to understand what is the level of redox potential of the juice we receive. Then we measure again in the tank, and you can see here in the graph that the orange dotted line corresponds to the temperature expressed in degrees Fahrenheit. 62 degrees Fahrenheit are approximately 17 degrees Celsius. The blue bars correspond to the redox potential, the average redox potential when it is already stable. So, we make 2 or 3 measurements a day, so this is not an absolute value, but a reference value. This gives us an idea of the initial situation. We have done these measurements more or less every year. The initial potential redox values are approximately 200, 300 expressed in millivolts, and below you see Brix. On the first day the value is 23.2 degrees Brix, and so here's my pointer. Then I added the yeast, and here there is a very rapid drop in the potential of reduction. So we started from 200 in this must, and already on the third day we have a value of 24.4 Brix and minus 50 millivolts. We continue measuring in the following days, and we realize that we get to negative levels. I have seen Chardonnays reach levels of minus 100, minus 150. We make Sauvignon Blanc, as a previous speaker said, so we process it for 2 or 3 days at a temperature of 17 degrees, and then we bring temperature down to approximately 12 degrees. Here you see that the temperature drops, the reduction potential is maintained, and then the redox potential begins to rise and reaches a level of approximately 150. I also recommend taking measurements of the redox potential on another occasion. I take measurements continuously, but one fundamental stage is when you bottle, before bottling. This is a study that I did comparing different types, different masses. We had a large tank, we had a probe on top with a higher reduction potential, more or less 140. Then there was a probe lower down, closer to the floor of the tank, where there were more lees, and there the reduction potential was lower. This is because yeasts have an internal reduction potential in their cells that is roughly 300 millivolts. So the closer the probe is to the lees, the lower the reduction potential. So I had this tank, and what we did was to filter the top part and put it into one separate tank, and we obtained a mass that had a value of 140 millivolts. The lower part, which we extracted using the lower valve, was put into another tank and filtered separately. In this case, the value was 87 millivolts. The central part was destined to another tank again, and the value was 103 millivolts. At this point, we brought together a dozen winemakers, gave them these samples and asked them to formulate, to express descriptors and tell us which sample they preferred. What we found is that when the redox potential is lower, the aromas were less fruity. The fruity notes were not so exuberant, the whites. There were aromas of white stones. You will tell me that white stones have no aromas, but it is an expression of minerality, and one could sense white peach, and to the palate it was more linear, and there was a tension. And the other sample, the sample with the higher redox potential of 140, there was more wood. We fermented this Chardonnay 100% in French neutral oak in new barriques, so we noticed the oaky note more. The sample was less floral. There were more notes of ripe fruit, more pineapple aromas. It was more expressive. You detected more melon and banana, and to the palate it was rounder and creamier. The fact is that depending on the experience of the winemakers, their preferences differed. In particular, we noticed that younger winemakers tended to prefer samples with a lower redox potential, while those with more experience preferred those with a higher redox potential. In my case, I tend to prefer those with a lower redox potential or with a value in between. This photograph reminds us of the fact that in the intracellular medium yeasts, these Saccharomyces always make an effort to reduce the redox potential of the must. And this is important, and that is why you have to play with the lees. If one realizes that the wine has a low redox potential, one has to remove some lees. In the past, we did not do it in the same way and did not measure the redox potential as we do today. Conversely, if one has an oxidized wine, one can add lees from another tank to reduce the redox potential. The management of lees is one of the most effective tools in managing the redox potential. Another occasion when I recommend to measure, as I said before, is before bottling. Sorry? Thank you. So, especially when one uses a transparent glass bottle. In the wine, we have cysteine and methionine, and in the presence of light. When there are light waves from 320 to 340, especially those fluorescent lights that they use in supermarkets, well, this light activates riboflavin and pantothenic acid and produces a reaction in which cysteine and methionine turn into dimethyl sulfide and dimethyl disulfide and hydrogen sulfide, and therefore there is a generation of mercaptans, some with tastes of garlic, others with a taste of cabbage or green beans. Well, these aromas evidently are not very positive for wine. None of us would like to have a wine that has this kind of aromas, so my advice is to measure first. The last question was, why should we measure? Of course, when we are responsible for a wine, we want it to have an absolutely perfect aromatic profile. We want it to be rich, optimal, pleasant. The fact is that the environment of the bottle is a reducing environment, especially when there is light, and this is something that naturally depends on the closure, on the fact that it is a cork or a screw cap. This will affect this environment, this reducing medium. As a result, it is crucial to be able to assess the risk of having a low redox potential during the time in the bottle.